Our world is connected. We can send a message to someone across the globe in seconds. We can video chat with family members in different countries. How is this possible? The answer lies beneath the ocean's surface. A vast network of undersea fiber optic cables carries the majority of our internet data. These cables, thinner than a garden hose, transmit information as pulses of light. They are the backbone of our global communication system. These cables are essential for our daily lives. They power our businesses, connect us with loved ones, and allow us to access information from every corner of the globe. Laying fiber optic cables across the ocean floor is a complex and challenging endeavor. Specialized ships equipped with advanced technology are used for this purpose. The process begins with surveying the seabed to map out the safest and most efficient route. Once the route is determined, a plow-like machine digs a trench in the ocean floor. The cable, carefully coiled on the ship, is then fed into the trench and buried beneath the sediment. This burial process protects the cable from fishing gear, anchors, and other potential hazards. The cable itself is made up of multiple layers of protective material surrounding the delicate glass fibers that transmit the light signals. These layers include steel wire for strength, copper for power, and a waterproof coating. The cable is engineered to withstand the immense pressure, cold temperatures, and corrosive environment of the deep ocean. The ownership and management of undersea fiber optic cables are typically shared by multiple countries and telecommunication companies. These entities collaborate to ensure the cable's operation and maintenance. International agreements and regulations govern the use and access to these cables. These agreements help to prevent disputes and ensure fair access to this critical infrastructure for all nations. The cables are designed with redundancy in mind. Multiple routes and connections are established to ensure that if one cable is damaged, internet traffic can be rerouted through other pathways. This redundancy helps to minimize disruptions and maintain a stable global internet connection. Undersea fiber optic cables, though durable, are not immune to damage. Earthquakes, underwater landslides, and even ship anchors can sever these vital connections. When a cable break occurs, it can cause significant disruptions to internet service in the affected regions. Repairing a broken cable is a complex and time-consuming process. First, the location of the break must be identified using specialized equipment that sends signals through the cable. Once the break is located, a repair ship is dispatched to the site. The repair ship uses a grappling hook or remotely operated vehicle, also known as an ROV, to retrieve the severed ends of the cable from the ocean floor. The damaged section is then brought on board the ship, where skilled technicians splice the cable back together and protect the joint with a waterproof enclosure. The repaired cable is then carefully lowered back into the ocean. Section 5. Starlink, an alternative approach. While undersea fiber optic cables form the backbone of our global internet infrastructure, alternative technologies are emerging to provide internet connectivity. One such technology is Starlink, a satellite internet constellation developed by SpaceX. Starlink aims to provide high-speed internet access to remote and underserved areas by deploying thousands of small satellites in low Earth orbit. These satellites communicate with user terminals on the ground, beaming internet signals from space. Starlink's advantage lies in its ability to reach areas where laying fiber optic cables is impractical or too expensive. However, satellite internet technology has its limitations. Latency, the delay in signal transmission, is typically higher with satellite internet compared to fiber optic connections. Section 6. The future of global connectivity. The future of global connectivity lies in a combination of technologies including fiber optic cables, satellite internet, and emerging innovations. As our reliance on the internet continues to grow, so too will the demand for faster, more reliable, and more accessible internet connections. Researchers are constantly working to improve the capacity and efficiency of fiber optic cables. New materials and manufacturing techniques are being developed to transmit even more data at even faster speeds. Satellite internet technology is also evolving rapidly. New constellations with lower orbits and more sophisticated satellites promise to reduce latency and improve bandwidth. These advancements will bring the benefits of high-speed internet to even the most remote corners of the globe. Section 7. Conclusion: a connected world. Undersea fiber optic cables and satellite internet constellations are marvels of modern engineering. They connect us in ways that were once unimaginable, enabling global communication, commerce, and collaboration. As we move forward, these technologies will continue to evolve, shaping the future of our interconnected world. The next time you send an email, stream a video, or connect with someone online, take a moment to appreciate the incredible infrastructure that makes it all possible. The invisible network of cables and satellites that crisscross our planet is a testament to human ingenuity and our desire to connect with one another. Section 8. Afterward. The exploration of our universe is driven by curiosity, a fundamental human trait. We yearn to understand the world around us, from the smallest particles to the vast expanse of space. Just as astronomers peer into the cosmos, seeking answers to profound questions, we must also turn our attention inward, exploring the intricate systems that connect us here on Earth. The story of undersea fiber optic cables and satellite internet is a story of human innovation and collaboration. It is a reminder that we are capable of achieving remarkable things when we work together towards a common goal. As we continue to push the boundaries of technology, we must do so with a sense of responsibility, ensuring that these advancements benefit all of humanity.